We looked at class-oriented curly without a type system. But if we try to run class-oriented programs, there are a number of things that might go wrong that we could rule out with a type system. For example, a typed class-oriented curly program should never raise a not a number error, just like it shouldn't with our lambda-oriented curly. And along similar lines, you shouldn't get a not an object error, which you would get if you try to send the mdist method to the number 1, for example, or if you try to get the x field from the number 1. Our type system for a class-oriented curly should rule that out. It should also rule out trying to instantiate a class like Posin3D with the wrong number of fields, because if we try to run this and there are a wrong number of fields, it would be an error at runtime. So the typed version should just not allow a program to run that would otherwise raise that error. And there should never be the error that a class is not found, or a field is not found, or a method is not found. For example, if we try to do new square circle and the class square circle has never been declared, then that should just not be allowed. We shouldn't be able to take a posin and try to get the z field of a posin when a posin only has x and y fields, and we shouldn't be able to try to call the area method of a posin unless the posin class actually has an area method, and this will succeed at runtime. Finally, we should not be able to try to call a super method if the class that our current class extends doesn't have that method. So since object doesn't have any fields or methods, then super area should not be allowed. It should be ruled out by the type system. To make this work, we're going to change our class-oriented curly, change the syntax of it to add some types. Our types are going to be either num, just like we always have literal numbers in our language, but the other kind of type that we have is a symbol, which will be a class name. So this symbol as a type must be some class that's declared with class and that same symbol. And then for each of our fields, it used to be that we would just have the name of a field in the class, but now we're going to have the name of the field and the type of that field. So when an object is created, that means the field value that's supplied must be consistent with the type that is declared in the class declaration. Similarly, methods, we're going to give a type to the argument and declare a type for the result. And so, of course, the type of the expression must be consistent with the type that is declared for the result, assuming the type that is declared for the argument.